In this problem, it says, determine whether the given function is linear or nonlinear, and if it is linear, determine the slope. So the first thing we're going to do is we're just going to look at our values as we deal with the x's. So what I mean by that is, when I take this from 0 to 5, my distance there is 5. And when I go from 5 to 10, that's also 5. Now, when we have a function that's linear, that value will be constant as I continue, or when I reduce it, should be the same value. So here it's going to be a plus 5. And then when I look at the gx values here, this distance is negative 15. This distance is negative 15. And this distance is negative 15. So when I look at all those, they're constant for both the x's and the y's. So that tells me there that this is actually a linear function, or this represents a linear function. So if the x's are a constant value, the y's have to also be a constant value in order for this to be linear. And this turns out to be a linear function here. So now it says if it's a linear function, it wants us to determine the slope. So that's easy. The idea of that is m equals change in y over the change in x. So my change in y is the negative 15, and the change in the x is 5. We did all the work already, and that's going to result in negative 3. So the slope for that, number 89, is negative 3. So now let's try the next one here. So the next one, we just do the same thing. So notice this, that's a change of 5. That's a change of 5. And that's a change of 5. So now the bottoms, now that's a constant change on the top, so just keep that in mind. So the first one here is 25. The next one there is 75. And then the next one after that is 125. So the top is a constant 5, and the bottom goes from 25 to 75, which is 50. A difference of 50, and then that's a difference of 50 as well. So it's like I'm adding 50 to get to the next one and then the next one. So it's changing. Right, so I start with 25, and then the next one's 75 that it increases by, so it jumps by an extra 50. And then to get to the next one, they add an extra 50 onto the 75, and then they get the 125. So that keeps increasing and changing the value. See, like on top, they're all the same. And that's what it should look like when it's linear. Since that doesn't occur here, this is not linear. Because if the numerator is, or not the numerator, I should say the x's are constant, then the y's definitely have to be constant. So this is not a linear function, or not linear. Okay, now for the next one here, let's take a look at this one now. This one goes from 0 to 5, so that's a 5. 5 to 10, that's a 5. And then 10 to 15, that's a 5. Again, they're constant. Okay, no problem. Now the bottom goes from negative 5 to 20. And that's going to be 25. And then 20 to 45, which is 25. And then 45 to 70, that's also 25. So you see on the top, the x, I should say the x, not the top. The x is constant because it's 5 every time. And the y is constant, or the f of x is constant because it's 25 all the time. So this would be linear. So this is a linear function. Oops. And I should have wrote that for the first one, and I didn't. I should have wrote linear here too. It said determine if it's linear, so I should have wrote it down there. I just did jump to the slope right away. So then the slope for this one then is going to be m equals, and the 25 is the change in y over 5, which equals 5. So my slope is going to be 5 for this one. And it's linear. So each one is a 2-part unless it's not linear. If it's linear, it's 2-part. So then for this one, there's my slope. And there's my answer to determine if it's linear or not. Okay, done.